By now we should be close to being factoring experts, so now we're going to focus on things we do with factoring. Right now that we know how to do all our factoring, we're going to use it in different ways. In section 10.7, we're going to solve equations by factoring. So a quadratic equation, we want it to look like this. We want ax squared plus bx plus c, that's a quadratic, and we need equals 0, just like when we were using the quadratic formula. Factoring is actually an alternative to the quadratic formula. So let's review the quadratic formula, just so we know what we're talking about here. So the quadratic formula for solving this same equation would be x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And that gives us the two solutions to this equation. Another way to do this is to solve by factoring. And especially once we're good at factoring, this can be a much easier thing than worrying about the quadratic formula. So the solving by factoring uses what's called the zero product principle. And what that means is that when we multiply two numbers or two expressions and get 0, then one of the numbers has to be 0. Because 0 times anything is 0, but it's the only way to multiply to get 0 is that one of them or both have to equal 0. All right, so those are the principles we're going to be using. We're going to factor and then set each factor equal to 0. It has to be in factored form for this to work, but if we have pieces that are multiplied and equal 0, well then each factor, one of the factors or both, have to be equal to 0. And we're going to see lots of examples of this in this section. First though, I want to make sure we're clear on what the difference between an equation and an expression is. Equation means we have an equal sign. Equations we solve, and then which means, figure out what x makes the equation true, what x values make the equation true. And what we're going to do once we find those x values is use curly brackets, and that's called the solution set. So that's what we do when we have an equal sign, right? Like ax squared plus bx plus c equals 0. That equal sign is what makes it an equation. An expression, on the other hand, has no equals. And what we do with an expression is to simplify. Typically that means to factor it. It could mean to reduce a fraction. If there's no equal sign, I'm not trying to get x by itself. We're just trying to rewrite it in a simpler way. So that's what we've been doing up to this point in this class, right? Every problem, if you look at previous sections, there weren't any equal signs. It was just, here, factor this expression. Now we're switching to solving. So let's see what that looks like. This says solve the following quadratic equations using the zero product principle. So we see there's an equal sign. That's what makes it an equation. And what we know is if two expressions multiply and give us 0, that either the first factor equals 0 or the second factor equals 0, or both. But the only way to multiply and get 0 is that one of the two numbers have to be 0. Well, now this is just, solving for x, right? It says solve. That means get x alone. So we have two different expressions to get x alone on. This one I'm going to add 5 because we're always doing opposite to solve. So in this case, the opposite of minus 5 is to add 5. So x equals 5. On the other side, the opposite of plus 1 is minus 1 to get x alone. So then x equals negative 1. So then our two answers we're going to put in curly brackets, because curly brackets is the formal way to write a list of numbers. So especially with these problems where we have two answers, we're going to list them in curly brackets. And all that means is that these are the two numbers that make this equation true, right? If I put in 5 here, 5 minus 5 is 0. 0 times anything is 0. If I put in -1, -1 plus 1 would make 0. Doesn't matter what this is. Actually, let's write it out, because now I'm thinking like, let's actually see these checks. All right, checking isn't so bad. So if I plug in 5, it'd be 5 minus 5 times 5 plus 1, which is 0 times 6. All right, this parentheses 0, that's 6. 0 times 6 is 0. If I try -1, -1 minus 5 times -1 plus 1 would be -6 times 0, that's 0. That's how we know these are the two answers. They both make the equation true. All right, so, I mean, and really, maybe we see already like, oh, we could have done that basically in our heads, right? Like, that's not too bad. Sometimes the factors are a little more complicated. So let's do an example of this. Still same principle. We're setting each factor equal to 0. So the two choices are 3x plus 4 equals 0 or 2x minus 1 equals 0. Well, in both cases, we're just trying to get x alone. So we do opposites. In the first one, I'm going to subtract 4 from both sides. So 3x is -4, and then divide both sides by 3 to get x alone. So x is -4/3. There's no reason to put a fraction in the calculator. -4/3 is a lovely number. Let's do the other side. I need to add 1 to undo subtract. So 2x is 1, and then I divide both sides by 2 to undo the multiply. So x is 1/2. So in this case, our two answers would be -4/3 or +1/2. And I'll leave it to you if you want to check.